Hi everyone, I'm Dr. Nick Behrman and welcome to our final session of the Foundations of Research Data Management for GIS course. Today we're going to talk a little bit about existing tools and applications. So there are many tools out there um, that might be useful for doing FAIR with GIS and research data management with GIS. Some of them may be useful for your project, some of them might not be useful. So I very much want you to take this as a list of things that might be useful. You'd need to review them and see if they are suitable for your project, because every project is slightly different, so one set of tools is not going to work for everybody. And we're trying to use these tools to make the work with research data management and make our data or our project fair or fairer, more fair. So findable, accessible, interoperable, and reusable. And remember, of course, that fair is a journey. It's not a binary yes or no. You're just trying to make it more fair. So one of the things I mentioned in the last session, we can go into a bit more now, is sharing GIS data using databases. So typically you'll store your GIS data in files, whether that's a shapefile, geopackage, geotiff, or other sorts of files. But if you've got multiple people editing data, it may be useful to have a database. The Postgres SQL is the kind of gold standard for spatial data. PostGIS is an extension to this. So they work together and they allow you to store spatial data, but they also allow you to do spatial operations within the database. And you can do things like, select all the points within 100 meters of this point, and the database understands spatial data and can look at this and say, okay, these are the points that you need, rather than having to download the data into your GIS, do the analysis there, and then create the output. It's worth mentioning Postgres SQL works very well with all GISs apart from ArcGIS Pro. Esri have got their own database format, which you'd need to use if you're using ArcGIS Pro. You can get them to work together, so with QGIS and ArcGIS Pro, but it's a bit of a faff. So if you do want to work with a database, there's a very good introduction to PostGIS workshop. So I'd recommend you start there, particularly the introduction page. It gives you a good scene setting on what the database is and how it works and when it's useful. I've always said if you're working on your own, you definitely don't need a database. If you're working with a larger group, so like more than 6 people, a database is really worth it, particularly if you've got more than 6 people editing data. If you're working with a small group of people, so 2 to 5, something like that, who are editing data, it's worth considering a database, but the benefits may not outweigh the time and effort of setting it up, because it is a bit of a faff to set up. There's quite a lot to do. So consider a database if you're in that situation, but look at other options as well. It's not the only option. So if we don't want to use a database, what are our other options? So there's a couple of approaches working with Git on spatial data. So CART is a relatively new piece of software. It works at distributed version control for geospatial data. So there's some nice resources on their website. GeoDiff is another approach doing similar sort of work, and this is the library that Mergin Maps uses for working with diffs of geospatial data. In general, CART is probably a bit more of an all-in-one solution, and GeoDiff is a bit more codey, a bit more behind the scenes. They're both worth considering. If you want to look at some of the other options of database or other options like CART or GeoDiff, there's a very good email thread on the QGIS developer list. So this started off with someone saying, we're storing data in SharePoint, it doesn't work, what can we do? And there's a bit of discussion, there's various different solutions that they might want to use. So if you're interested, have a look at that list. And we can use Git with spatial data, but it doesn't really work very well with binary files. So shape files or geopackages, it can't do the difference. So you can store binary files in it, but it won't be able to tell you you've added this vertex, you've added this point, you've added this line. You'll just say it's changed. Also, Git doesn't really work very well with large files. So this is specifically anything over 100 megabytes. Git itself will work, but GitHub will not work. So if you try and commit files over 50 megabytes on GitHub, you'll get a warning. If you try and commit a file over 100 megabytes on GitHub, you'll get blocked. So you won't be able to do that. And GitHub also say that large repositories, so they're defining this as anything over 10 gigabytes, will have very slow performance. So be a little bit careful when you're committing data, particularly large amounts of data. So there's a link on GitHub website which talks about the limitations. If you do end up doing it, I would say that using the command line tool, Git, to do the commits and so on, is a lot faster than using GitHub Desktop to do the commits. So that can be an advantage if you end up doing that. There are some other tools for working with large data. This is large data in general, not GIS specifically. So Git Large File Store is probably one of the key big ones. So here they move the large files out of your Git repository and use text pointers to refer to them. It integrates with most of the different repository areas, so GitHub, GitLab, and Bitbucket. Git Annex is a similar approach, but a little bit more codey. DataLad is a kind of interface for Git Annex, which makes it a lot easier to work with. DataLad has a kind of good online workshop where you can have a look and see how it works and see whether it might work for your project. If you're interested in this, there's a great article on version control for data in the Turing way, so check out that if you're interested. Some of these options can be quite complicated, and whether it's worth it or not for your project depends how much data you've got and how important the version control is. A simple example is to have a data folder in your repository and then ignore that from the repository, so exclude it from the repository, put it in your git ignore file. And then you've got version control for all the code, but you don't have version control for the data. So you could have a log of the data in a README or an Excel file, so just a list saying, this is the data I'm using, this is where I got it from, this is some details about it, and so on. And you could have that as a snapshot of the data. So this is the data you're using. And if it does change, you can replace it with updated data. And this gives you the benefits of Git without the large file problems. If your data is static, this would work quite well. If your data changes a lot, then it probably doesn't work quite so well, but it depends what exactly you're doing. If we're sharing data in the field, we can use a number of apps for this. So QField or Merging Maps are two very good apps for this. The way this works is you set up your project in QGIS, so you add all your layers, work out what data you're collecting. So you have like a template almost for what variables you're collecting. Are they strings, are they numbers, and so on. And then you can share this to your mobile or tablet device. Then you can give that to several different people. You can go out into the field, use the GPS to record whatever it is you want to record, and then synchronize that back to the project in QGIS. QField has been around a bit longer and is probably more flexible, more customizable in terms of the interface. Merging Maps is a bit newer, but it has a more polished interface, I would say, than QField. They both have pros and cons. They both integrate the data really well, so that's one of their key examples. I'd also say support for Android devices is better than iOS devices in general. There are exceptions, so if iOS, iPhones, iPads are key for what you want to do, have a look into that and see which one might work best for you. Thanks very much to NFDI4Earth and the Digital Research Academy, and thanks to everyone who contributed to this material.